Minimum velocity for vertical motion. A ball is attached to the end of a string. It is swung in a vertical circle of radius 0.75 meters. What is the minimum velocity that the ball must have to make it around the circle, to come all the way around and wind up back here? The important point for this problem is to worry about the ball when it's at the top of the circle, where your forces are mg pointed down and tension force pointed down, and your acceleration pointing towards the center of the circle is also down. If you want to make it around the whole circle, the tension needs to be greater than 0 at every single point. If not, what if we have no tension? Well, then the only force acting is gravity, which means you're in free fall, which means you're falling straight down. You're not making it around the circle. So the way we're going to solve this is set the tension force equal to 0, and then solve for that velocity. That will be V minimum. For any velocity greater than this, the tension will be greater than 0, and the ball will make it around the circle. Any velocity less, there'll be no tension, and the ball will fall straight down. Well, it'll still have some forward motion, but it's going to fall down. It's not going to make it around the entire circle. So we've done the hard part by conceptualizing what's going on here. Now we have our free body diagram, and we take Newton's second law again, and we have the tension and mg are both pointing down, so they're negative, and the acceleration's negative, so everybody's negative here. The very next step is to set tension equal to 0. That's what we talked about on the last slide. And at the same time, we're going to save an algebraic step here. We'll divide both sides by -1, or multiply by -1. Either case, you get mg is equal to ma. We then isolate g by dividing both sides by m, and what do we have now? We just have g is v squared over r, right? The m's cancel out. It does not depend on the mass of the ball. And we're trying to solve for v, so once again we take a little shortcut here. I'll just write the steps out here. Multiply both sides by r, right? So you get gr is equal to v squared. Then we'll switch sides around because we're solving for v. V squared is gr. And since we want v, we then take the square root of both sides. Square root of v squared is v. Square root of gr is square root of gr. Then we can put our numbers in, and we find out that the velocity is 2.7 meters per second. And that means when we're swinging the ball around, it'll continue the loop just like that and go in a total circle.